In example 2, we're going to go through one more problem. We're going to find the maximum, or this time we're only going to find the maximum value of the function z equals 2x plus 7y, subject to the following constraints. So here are the inequalities we have. So we want to start by graphing those inequalities. If we do the first one, we have 5x plus 11y is less than or equal to 88. If we start solving for y, we have to subtract 5x first. So we'd have 11y is less than or equal to 88 minus 5x. And then we would divide everything by 11. And we get y is less than or equal to 8 minus 5 over 11x. If we go and graph that, I'm going to move this up just a little bit so we can see the full graph. If I look at my scale here, I have enough to go up by ones. If I glance at my other equation, 14 is at y-intercept, and I do have 14 going up in this direction. So we can go up by ones. So graphing this makes it a little bit easier. I have a y-intercept of 8, so let's go ahead and plot that. Here's 5. And my slope tells me to go down 5 and to the right 11. So let's do that. So we're going to go down 1, 2, 3, 4, 5, and to the right 11. And that will give us a point right there. I could look to go down 5 again, but if I try to go down 5 again, you see 1, 2, 3, then I'm off my graph. So those are really the only 2 points that I can plot. So it's very important here that you try to get as straight of a line as possible. Okay, then I'm going to go to my next line, which is x plus y is less than or equal to 14. So to solve for that one, I just have to subtract x from both sides, and I get y is less than or equal to 14 minus x. So my y-intercept here is 14. So if I have 8, 9, 10, 11, 12, 13, 14, I'm right here. And then my graph tells me to go down 1 and to the right 1. And I can plot as many of those points as I can. Again, the more points you have, the better off it's going to be, or the easier it's going to be to find those vertices. Oops. And then let's go get that straight line in there. Then we can't forget we still have our graph that x is greater than or equal to 0. That's my vertical line. And we have the graph that y is greater than or equal to 0. So that horizontal line here. And then we have to figure out where to shade. So if I take a look at the green, well, the blue and the yellow, we know tell us that we're in this first quadrant. So we're bigger than the blue line. We're above the yellow line. Now we've got to figure out the other two. So my green line, it says that it's less than or equal to that. So if I picture that guy walking, that guy would be walking along the line up here, which means I want to be somewhere underneath here. So I have two areas, this area here or this area here, depending on what the red line is. My red line tells me that I'm less than or equal to. So if I take a look at my red line, if I picture that guy walking, he would be right here walking along the line. So this is the top of my line. Underneath my line is here. So underneath my red line, I would have to be here, and I'm underneath my green line. So this is the area that I want to shade. So I'm going to go ahead and shade in that area here. Then I have to go ahead and list my vertices. So let's list those vertices. As I travel along my graph, my first vertice that I see is this one right here, the blue and the yellow line, which is the point 0, 0. Then as I travel along my shaded region, I get to this point, the intersection of the green line and the blue line, and that was at the point 0, 8. So I know I have 0, 8 as a vertice. Then if I continue to travel along my shaded region, I come to the intersection of the green and the red line, and I know from my graph, since I've plotted those points very accurately, that intersection is going to be pretty easy to find. I don't have to go through and solve that system because it's an exact point right here. And that is my point. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3. At 11 and 3. And then if I continue along my shaded region, I get to the intersection of the red and the yellow line, which is at the point 14, comma 0. After I go ahead and do that, then what I need to do is I need to find out those values at my objective function. So I'm looking at my vertices at z equals 2x plus 7y. So if I plug that in, for my first one, I get 2 times 0 plus 7 times 0, and that gives me 0. If I plug in 0 and 8, I have 2 times 0 plus 7 times 8, and that will give me 56. The next one, I get 2 times 11 plus 7 times 3, and that will give me 43. And my last one, I have 2 times 14 plus 7 times 0, and that gives me 28. So I'm looking for that maximum value. As I look through these numbers here, the biggest number I have is the 56, which means 56 is my maximum value, and I get that by the 0.08. So I can say for my final answer that the maximum occurs at 0, 8, with a max value of 56. What I'd like you to do next is to try this that's underneath here. When you're done with it, then you can unpause it and check your answer. So go ahead and pause it now. If you did it correctly, you should have this as your answer for the try this. If you have any questions, please let me know.